Hello, I'm going to go over this concept of nebula condensation. And what we get with nebula condensation is we get the process of going from dust and gas to solidifying into larger things like rocks and boulders and asteroids. Condensation, you can think about like the air outside will condense onto your cold iced tea glass, going from a gas to a liquid. We're doing something similar here. So we're talking about when the solar system forms, and as it's coming together as this accretion disk, there's some areas that have a different temperature than others. And since most of the material is falling in towards the sun, most of the friction is happening up close. So the hottest part is up close. Close to the middle of the disk, it's hot. And then the temperature gradually cools as you go further away. So we have a medium temperature here. And then eventually it's far enough away where it's cold. There's not enough friction to really heat up this material. Most of the material is down in towards the center. So like we said, this stuff is swirling around, colliding with each other. It creates a lot of friction, and that's the heat that is warming up this area. What that means is it's hot enough here that the gases that will make up some of the other planets, those gases, it's too hot for them to form into solids, so they stay gases. So the first thing that start to form into solids in this hot material are things like rocks, silicas, and metals, iron, nickel, etc. And what we end up getting, because these rocks and metals are the first things to solidify in this heat, is we'll get our rocky planets. This is Mercury, Venus, Earth, Mars. So our rocky planets form close to the sun. And then you get out to past a certain point, and this point, we can kind of like, oh, my pencil doesn't do it, but we kind of draw a circle around the solar system this way, because this is the frost line. After this point, it's cold enough for some of the lighter elements and gases to start condensing, to start solidifying. And what we get are things like hydrogen gases, helium, and some of the lighter volatile gases can now start coming together and solidifying, because it's cold enough out here for that to happen. And those gases will eventually form our gas giants. Now, if it was cool enough on the inside of the solar system, they would form closer to the solar system, but it wasn't. Most of the heat was in there, so they had to form outside of the frost line. And then finally out here, you also get this kind of like right around where the frost line is. In our case, we got an asteroid belt. It's kind of that go-between between where we have the rocks of the inner system and the gases and ice and water vapor of the outer system. And this all, so copy this down. This was all because of different temperatures in our newly forming solar system. That's why we see, that's why we see this differentiation of planets. All right, thank you very much.